Got a whole bunch of theorems for you today. Not a whole bunch, maybe 2 or 3. Of the 3 theorems, one of them is really the only one that we care about. The other ones are okay, they're great. Oh, look, we've seen them. But there's one in particular that's going to be fairly helpful. First thing first, definition of inequality. If you don't know what inequality means, there is the formal definition. We talked about equality. In fact, we didn't talk about equality because it's assumed that everybody understands what it means for 2 things to be equal. But what does it mean for 2 things to not be equal? One being bigger than the other. That is the formal definition. A is greater than B if there's some number C that you add to B to make it equal. I don't restart. Do we really need to talk about inequality any more than that? You understand what A greater than B means and what A less than B means? Yes?
Yeah. Okay,
good. I'm not going to spend a whole bunch of time on it. But you should probably see that formal definition. So, last chapter, I think. Or the chapter, I think it was last chapter. We did the exterior angle theorem. Yes? Mm-hmm. What's the exterior angle theorem say?
If you add the interior angles, it equals to the exterior.
Beautiful. Question?
Never mind.
You were going to say what he said?
Yeah.
He just beat you to it?
Yep.
You snoozy, you losey. Now we have the exterior angle inequality theorem. So before you go writing like mad people, let's talk about this logically. The exterior angle theorem said that angle 1 is equal to angle 2 plus angle 3, correct?
Mm-hmm.
All this does is say that if angle 1 is equal to 2 plus 3, then angle 1 has to be greater than 2, and angle 1 has to be greater than 3. Fairly common sense, yes?
Yeah.
Good. So you can write down all you want, but it's a pretty easy theorem. And again, we're dealing with angles that always have positive values. That's what makes this work. If we had something like a negative angle, it would screw everything up. Just make sure that as we continue to do things, you are able to make the distinction between the exterior angle theorem, which involves equal sign, or exterior inequality, which involves an inequality symbol. Are we good here?
Sure. Mm-hmm.
Awesome. Okay, so which one's bigger, 7 or 8? Now you're going to have a tendency to say, well, obviously it's 8. 8's an obtuse angle, 7 is acute, 8's got to be greater than 7. However, you will quickly learn, especially when dealing with inequalities, to not trust the picture. So we'd like to be able to explain, well, first of all, we want to be able to find the answer. And then we want to be able to explain it using theorems, not using the picture. So which one's bigger? You've answered already. You're entering the Paul realm. You know what I'm saying? You know? Yeah. Thanks. Which one's bigger? No.
Come on.
Go, you can tell him.
8.
No, tell him. Don't tell me. You
Okay.
can't talk. You use one. Yeah, Deb?
8.
8. Excellent. Deb? Why? Hey, now you're going like a muppet.
Can this say it? Yeah. Okay. 4 and 6 are
You
the.
didn't even wait for my answer.
Okay, 4 and 6 are the exterior and interior.
Oh, so you need help.
Then you tell us.
That's how he talks. Oh, you're actually waiting for me?
Yep.
Uh-oh.
Did you just say uh-oh? Roll. Would have gotten away with it. It wasn't for you pesky kids and your stupid dog. All right, Emmett, what do you got?
8 is greater than 7 because 7 is an interior angle and 8 is an exterior angle.
No.
I think I got
No. There's two ways to solve the problem. What do you got, Michelle?
I was thinking 8 is greater than 7 because 8 is equal to the sum of 7 and 3 because 4 is an exterior. 4 would be the same as 7 and 3 together because it's like the exterior of that, and then 5 would be supplementary to 4, and then 8 would be supplementary to 5.
No. 4 is equal to 7 and 2, not 7 and 3. But you're not that far off. What else you got? Are you just stretching or?
Yeah.
All right, I understand. I'm not giving you this one. You got to work for it. What do you got?
Could you look at like the bigger triangle, like the full triangle?
We can do whatever you'd like, Ashley.
So like angle 2 and angle 7 and 6.
So you want to consider this one big honking angle.
Yeah.
All right, we'll call it angle beta. That's a beta. It's a B with a tail.
Okay. Angle 8 is bigger than 2 remote and interior angle, so it'd be bigger than angle 7.
Right. Angle 8 is greater than angle 7 plus angle 6, which is the same thing as beta. And so if 8 is bigger than the two of these added together and they're both positive values, then that tells you that angle 8 is greater than angle 7. Does everybody get that? Okay. There's another way to do it, however. There's nothing wrong with that method. I like that method. But there's another method that you can use to tie the two triangles together. If I look at this triangle, then I know that angle 8 is greater than angle 4, and angle 8 is greater than angle 6. Okay, that's just an application of the exterior angle inequality. Now, changing colors here, if we look at this triangle, I know that angle 4 is greater than angle 7, and angle 4 is greater than angle 2. How do these four statements allow me to get to there? No. Put your hand tone. Morgan.
Because if 8 is greater than 4 and 4 is greater than 7, then 8 has to be greater than 7.
Beautiful. Okay. Angle 8 is greater than angle 4. Angle 4 is greater than angle 7. So therefore, have we done that? 3 dots, therefore?
No.
Well, now you know. New symbol for today. Therefore, angle 8 is greater than angle 7. Two different methods to get the same answer. Both of them are correct. It's just a matter of how you see it. I would guess that most people, as you get more adept in this inequality stuff, you're going to go with the second method. For some reason, people don't like to stick angles together. Paul? You're just waving your hands in the air like you just don't care?
Yeah.
I understand. We good? Okay, next question. Get rid of this mess. Come over here. Doink. Doink. Which angles are smaller than angle 1? And again, don't trust the picture. Michael.
That'd be angle 7 and angle 3.
It's a good start. That's half the answers.
Like pass it on to somebody else.
Oh, sure, yeah.
Angle 2.
It would appear that way, but doesn't necessarily have to be. We do know that 1 and 2 are supplementary, and from the picture it appears that 1 is obtuse, so therefore it would be bigger than 2. But again, don't trust the picture. It could conceivably be an acute angle. Right?
6 and 5.
Correct, 6 and 5. Okay. Is that it? 7, 3, 6, and 5. Seven, 3, 6, and 5. Correct. Okay. We know nothing about the relationship between 1 and 8, nor the relationship between 1 and 4. And even the relationship between angle 2. It appears that angle 2 is smaller than angle 1, but again, appears isn't going to cut it for us. Okay. Let's get on to the more important theorem. SML stands for small, medium, large. This is a pretty big deal. If you look at that picture, I gave you the 3 angles. First of all, that's a triangle, right? 100 plus 50 plus 30 is 180, so we know it's going to make an actual triangle. Which side is the longest? Nicole?
BC.
BC, Badger Cat?
Yes.
Correct. Which side is the shortest? Nicole?
Oh, AC.
Alligator, crocodile, and that would make the middle side
AB.
aardvark, badger.
Yes.
Well done. That's what the small, medium, large theorem says. The largest side is always opposite the largest angle. The smallest side is always opposite the smallest angle, and the medium side is opposite the smallest angle, or medium angle. Okay. And so you got 2 ways to go with that. Here are 3 angles, compare the sides. Here are 3 sides, compare the angles.
So the longest side is opposite the
Largest angle. Smallest side is opposite the smallest angle. And the medium side is opposite the medium angle. And of course, that changes if we have something like an equilateral or an isosceles triangle. We're not going to really, I mean, that'd just be silly. You know how that works. We'll ignore that. Just talk about a plane triangle. The next couple slides then are the fancy geometric hoity-toity definitions for that small, medium, large theorem. I would suggest that you not write them down, but if you want to, this is America. Fight the power. Right now. If I can get my clicker to, whoa, jump the gun. So there they are. Great, make perfect sense? Good, let's move on. Which angle's biggest? Mary? No?
I guess then?
I'm sorry?
I guess then?
Sure. I guess I'm not answering the question. The question does say smallest to largest, so let's change it, Mary. Which angle is the smallest?
Angle. Q?
I'm sorry?
Q?
No, that is incorrect.
R?
R, good. Got a 50-50 chance. Y,
Because it's opposite the smallest side.
good. Which one's the medium angle?
Is it angle Q?
Q. And which one is the biggest?
Angle C.
There you go. Any problems? Awesome. Pretty easy. Now list the sides in order. Ooh. Yeah.
Yeah, let's go.
Shut up. Get out your calculators, do some work. It's good for you. Puts hair on your chest. It's so horrible. I have to solve a linear equation on a Monday against the Geneva Convention. Attica, Attica. You guys don't even know what that means.
No, we
No.
don't. Okay.
Paul, solve. On paper. So Vanessa can copy off of you.
No, I'm looking at the room. Wait, I don't even need that. Wait. I'm smart. I have it as a widget on my iPad.
I don't wanna get my calculator out.
Widget.
That is like a wing.
I don't want to reach a foot and a half down below my back.
I have clothes in my bag.
You're lazy.
Borrow Jack's.
Jack has a disgusting calculator.
Give me a
Wow.
second.
Oh, it's on now, Jack.
I feel like I did that really
Okay, I think I got the wrong answer.
Fractions are okay, guys. The answer's 5.
Thanks, Madeline.
Ew, wait, 5. What? X equals 5.
Okay.
You just said it's not 5.
Oh,
yeah, it's not 5.
I said that.
Oh my.
Did you like subtract 5 instead of add 5? Yeah. Sorry.
Happens all the time.
185 divided by 3 is
It's, oh gosh, I'm scared by this number.
Oh, yeah.
X equals basic.
You better start.
Oh, that's nice.
Circle move.
Thing. Let's just round into 2 decimal points.
Yeah.
What?
Ugly numbers are the best.
No, they're not.
Yes, they are.
No, they're not.
Like my class.
That's nice.
Dang.
I'm using
That was beautiful, Matt.
Thanks. I hate this desk.
Are we supposed to find out?
Divide it.
Grace, what's the answer?
Hey, Grace.
Oh, I did English.
Good job, Grace.
Okay, the shortest is NM.
Narwhal mongoose.
Yeah.
Okay.
The middle side is NL.
Newt llama.
Yeah.
Uh-huh.
And then the longest side is ML.
Monkey line.
Yeah.
Is she right?
Yeah.
Okay, tell us how you did that, Grace.
I added all the angles together to equal 180.
And what travesty did you get for X?
185 over 33.
Yeah, excellent.
Wait, you guys got that?
Yeah.
Yeah.
What did you get?
X equals 5.
What?
It still worked.
That's a problem.
Well, no, it didn't work. You just got lucky. How did you get X equals 5? I don't want to know. I do want to know, actually.
Wait, what's 180 minus 15?
You're an L.
It's not
It's
minus
Where you get a
1.
15?
Minus 5.
It's minus 5. It's plus
Well, minus
5
10.
5 plus negative
It's
10 is
plus 10
negative
minus
5.
Plus 5.
Oh, so it'd be 190 minus 5 to be 180.
I know, it'd be
185.
Okay, well, it still works. It's okay.
Oh, yeah, sure. Even though you get the problem wrong. Trace, back to you. So then you found out that X was what'd you say, 185 over 33? And then did what?
I plugged it in for X and then found the angles.
Good. And in this case, where we're dealing with angles, you know that they're gonna work because we forced it to work, so you don't have to check to make sure it's a triangle. It's gonna be a triangle. Found the measures of the angles and then use the SML theorem to get that final answer.
Whoa, it hurt.
Well done. Any problems? Hot diggity, we're all done for today.
Dude, want that.
Can't believe
Apple and Cheerios and Walmart.
It's just Madeline. It'll be alright.